Okay, so this is a multiple part question then. Part A, B and C seem fairly easy, mainly just relying on GCSE stuff. Part D is a fairly difficult integration question. We'll start right from the beginning though. So first part is verify that C crosses the x-axis at point 1, 0. All I'll do is just plug in x equals 1 into the equation of the curve and hope that I get 1 out of it. So y equals 1 to the power of 2 over 3 minus 2 over 1 to the power of 1 over 3 plus 1. So I'm hoping to get 0 out of this. Y equals 1 to the power of 2 over 3 is just 1 minus 2 over 1 to the power of 1 over 3 is just 1 plus 1. Y equals 1 minus 2 plus 1. Y equals 0. So the point 1, 0 does lie on the curve. Right, part B, it's the same thing. Instead of plugging in x equals 1, we're plugging in x equals 8, and instead of asking, we're hoping for y to be equal to 0 when we do that, we're hoping that y is equal to 4. So 8 to the power of 2 over 3 minus 2 over 8 to the power of 1 over 3 plus 1. Y equals, well, the cube root of 8 is 2, and 2 squared is 4, minus 2 over cube root of 8 is 2, and plus 1. Y equals 4 minus 1 plus 1. Y equals 4. So again, we've shown that the point 84 does lie on the curve by plugging in 8 and getting 4 out. Okay, part C. The point 40 is B. Find the equation of the line AB. So let's remind ourselves, A is the point 84 and B is the point 40. If I'm finding the equation of a line, I need the gradient and the y-intercept. So the gradient is equal to change in y over change in x, which is 4 minus 0 over 8 minus 4 is equal to 4 over 4, which is equal to 1. So the gradient of this line is 1. I'll plug it into any coordinate here, so let's call, we'll plug it into this coordinate here, so 4 is equal to 1 lot of 8 plus c. C clearly then is minus 4. So to answer the question, the equation of the line, y equals 1x, so just x, minus 4. So that's part C done as well. As I mentioned at the start, part A, B and C are already just GCSE material. Part D, we'll have to use some A-level knowledge there. So part D says the finite region R is bound by the curve C, the line AB, and the positive x-axis, and we need to find the area of R. I think the difficult thing about this particular question is it's quite hard to visualize what that curve actually looks like, but we should focus on the things that we know. For example, we know that it crosses through the point 1, 0, it crosses through the point 4, 8. The power of the x here is 2 over 3, so I'm going to assume it's a concave shaped curve. It doesn't cut through the y-axis because x being equal to 0 is undefined. So I'm going to draw a concave shaped curve looking something roughly like this. I'm going to ignore the negative x values because it won't be relevant for this question. So that's the curve roughly sketched for positive x values. Now I will sketch the line AB. Just like the curve, it crosses through this point at 84, and it also crosses through the y-axis of minus 4. So it will look something like this with a gradient of 1. This question is important to realise that this point here is 4, 0. How do we know? Well, at the x-axis, y is 0. So if y equals x minus 4 is the equation of the line, at the x-axis it will be 0 equals x minus 4, and then clearly x would have to be equal to 4. So this line crosses the curve at x equals 4. Alright, so the question wants the region R. The region R is defined as the region bound by the curve, the line, and the positive x-axis. So think of being bound as being surrounded by those particular things, like a country surrounded by those particular borders. So this seems like it would be the region R, because it's surrounded by the curve, the line, and the positive x-axis. To find that shaded region R in orange, I think we should integrate below the curve between the values x equals 8 and x equals 1, and then take away the area of this triangle, and that will leave us with the orange area there. So that's what I'll do now. We're going to integrate that curve. So the integral of that will be 3 minus plus 1 between the values of 8 and 1 with respect to x will be equal to, we'll add 1 to the power to make it 5 over 3, divide by the power to make it 3 over 5, x to the power of 3, that's the power of 5 over 3. I'll just call this power 2x to the minus third, so I'll just adapt it here, 2x to the minus third, and get rid of that denominator. Add 1 to the power to make it 2 over 3, then divide by the power, so we're going to do 2 divided by 2 over 3, which is the same as doing 2 times by 3 over 2, so that'll be 3, so minus 3 lots of x to the power of 2 over 3, and then 1 integrated becomes just x between the values of 8 and 1. Okay, so now I'll plug in 8 in for x. So we have 3/5. Okay, 8 cube rooted is 2, and the power of 5 is 32. Minus 3, 8 cube rooted is 2, the power of 2 is 4, so 3 lots of 4, and then plus 8. I'll put square brackets around all of that. And then on minus, and just plug in x equals 1 now. So square brackets, 3 over 5 lots of 1 cube root is 1, the power of 5 is just 1 as well, minus 3 lots of 1 to the power of 2 over 3 is just going to be 1 as well, and then plus 1. Okay, now some mental maths here. 3/5 of 32 is going to be 96 over 5. So 96 over 5 we'll call 19.2. So just going here, this will be equal to 19.2 minus 12 plus 8, and then minus and we're going from here to here now. 3 over 5 times by 1 is 3 over 5, minus 3 and plus 1. Okay, 19.2 minus 12 is 7.2. 7.2 plus 8 is 15.2. Minus 3/5. So 3/5, let's do a bit of a side note here. 3/5 minus 15/5 plus 5/5 is equal to minus 12/5 plus 5/5. That's minus 7/5. So we're going to minus 7/5, which is equal to 15.2 plus 1.4, which is equal to 16.6. Okay. So with 16.6, what we found there is the region underneath the curve between the x values of 8 and 1. So basically we found that region there. But we don't want that region. We only want this orange region here, which means we must take away the area of this triangle. Okay, let's just draw this triangle out here. And this won't be too difficult. So the x values on that triangle, this x value was 8, this x value was 4, therefore the triangle has a width of 4. This y value was 4, this y value was 0, so it's a height of 4 as well. So the area of the triangle was 4 times by 4 over 2 equals 8. And therefore, if the total area is 16.6 and the area of the triangle is 8, then this orange region here is just going to be 16.6 minus 8, which is equal to 8.6 units squared. And that is the final answer.